Welcome to this crash course on Precalculus. Let's get started. First, let's talk about functions and their graphs. The slope of a line can be written as m equals y2 minus y1 divided by x2 minus x1, where x1 is not equal to x2. This can be rearranged to give the point slope form of the equation of the line, which is y minus y1 equals m times x minus x1. Parallel lines have equal slopes, while perpendicular lines have slopes that are negative reciprocals of each other. The domain of a function is the set of x values for which the equation is defined, while the range of a function is the set of y values for which the equation is defined. The parent functions are linear, quadratic, cubic, absolute value, square root, and rational, with a few of their graphs shown. We can shift graphs through vertical shifts, horizontal shifts, reflections in the x-axis, reflections in the y-axis, and stretches and compressions. To add, subtract, multiply, divide, and find the composition of functions, we can use the equations as shown. If f and g are two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f, the functions f and g are inverse functions. Now, let's talk about polynomial functions. To start, quadratic functions are u-shaped parabolas written as f of x equals ax squared plus bx plus c. Their standard form can be written as f of x equals a times x minus h squared plus k, where the parabola's axis is the vertical line x equals h and vertex is the point h comma k. The parabola opens upward when a is greater than 0 and opens downwards when a is less than 0. Polynomial functions like parabolas are expressions such as x squared minus 3x plus 5. The graph of a polynomial function is continuous with no breaks, holes, or gaps, and has only smooth, rounded turns. To divide a polynomial by another polynomial, we use long division, and to divide a polynomial by a binomial of the form x minus k, we use synthetic division. See the examples for each. There are many theorems and tests we use when dealing with polynomials. The tests include the leading coefficient test, the rational zero test, and Descartes' rule of signs, and the theorems include the intermediate value theorem, the remainder theorem, the factor theorem, and the fundamental theorem of algebra. We can use the leading coefficient test to determine the end behavior of graphs of polynomial functions, as shown. We can use the rational zero test to determine possible rational zeros of polynomial functions. Descartes' rule of signs is used to find the zeros of polynomials. We can use the intermediate value theorem to help locate zeros of polynomial functions, as shown. The remainder theorem states that if a polynomial f of x is divided by x minus k, the remainder is r equals f of k. The factor theorem states that a polynomial f of x has a factor x minus k if and only if k equals 0. Finally, the fundamental theorem of algebra states that if f of x is a polynomial of degree n, where n is positive, then f has at least one zero in the complex number system. Speaking of complex numbers are numbers of the form a plus or minus bi, where I is the imaginary unit and a and b are real numbers. The imaginary unit I is defined as I equals the square root of -1, where I squared equals -1. Exponential functions are functions noted as f of x equals a to the x, and logarithmic functions are functions noted as f of x equals log base ax. Here's what they look like graphically. Also, see the following log properties. Trigonometric functions are functions involving sine, cosine, and tangent, and their respective inverses cosecant, secant, and cotangent. The equations for these are as shown, along with the fundamental trigonometric identities. The unit circle, as shown, allows us to visualize the x and y, or cosine and sine values, for various angles. To convert degrees to radians, multiply degrees by pi radians over 180 degrees, and to convert radians to degrees, multiply radians by 180 degrees over pi radians. Finally, it's important to recognize the graphs of trigonometric functions of the form y equals d plus a sine bx minus c, where sine can be replaced by any trigonometric function. A stretches or shrinks the amplitude of the graph. B shifts the period of the graph, which is 2 pi over b for sine and cosine related graphs, and pi over b for tan related graphs. C shifts the graph left or right, and D shifts the graph up or down. Let's quickly touch on analytic geometry. The fundamental trigonometric identities are as follows, and the guidelines for verifying trigonometric identities are also as follows. Finally, shown are the sum and difference, double angle, half angle, product to sum, and sum to product formulas. To find missing sides of triangles, we need to know a combination of 3 angles and or sides, where angles are represented as A and sides as S. So an AAS triangle has 2 known angles and 1 known side. For AAS, ASA, or SSA triangles, we can use the law of sines to find the other missing angles and sides. For SSS or SAS triangles, we can use the law of cosines. To find the area of a triangle with sides of length A, B, and C, we can use Heron's formula as follows. Another interesting topic is vectors, which are basically directed line segments. They are composed of an x or horizontal and y or vertical component, which combined cause the vector to point in a certain diagonal direction. We can solve linear systems of equations in 2 variables using substitution, elimination, and graphing. We can represent these systems of equations as matrices, which are arrays of numbers. Matrices are more easily manipulated, and we can perform various operations with matrices, such as adding, subtracting, and multiplying. Here are the notations and formulas for sequences and series, which include infinite series, arithmetic sequences, geometric sequences, and infinite geometric sequences. Additionally, here is the notation for permutations, combinations, and probabilities of events. See our video on probability and statistics for a more in-depth look at this topic. There are 4 basic conics: circles, parabolas, ellipses, and hyperbolas, whose formulas and graphs are as shown. When talking of the 3 dimensions in a coordinate system, we have a z-axis on top of the usual x and y axes. The distance between the points x1, y1, z1 and x2, y2, z2 is given by the distance formula, and the midpoint of the line segment joining these 2 points is given by the midpoint formula. And that's it. Thanks for watching, and I hope you found this video helpful.